Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, TIFR, Jest, IIT-Jam and other exams related to physical science. Okay. So this is the lecture number 4 of condensed matter physics. Okay. And also I would request the student who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. Okay. So I'm going to start. Okay. So this is the lecture number 4 in which I'm going to discuss crystal structure and Miller indices. Okay. So this is the so first we'll start with zinc blend structure, ZNS structure. Okay, so this is zinc blend structure. Okay, zinc blend structure, or that is ZNS structure. Okay, ZNS structure. Okay, so this is ZNS structure we are going to study. We also say it zinc blend structure. Okay. Well, meanwhile, just let me check whether I'm audible or not. Then I'll proceed further. Okay. ZNS structure. Okay. Yeah, I'm audible, so I'm going to proceed further. Okay. So the ZNS structure. Okay. All the points which I'm writing, guys, which are very important for the exam purpose. Okay. So it's a DC lattice. So it has a DC structure, diamond cubic structure. Okay. DC lattice with two atoms bases. Okay. Two atoms bases. Okay, so it has a diamond cubic structure. Okay, so DC lattice with two atoms bases. Okay, so here because I'll show you that this is, so S atom has FCC structure. Okay, and N effective for S atom is 4. Okay, and that is Zn atom has tetrahedral structure. Okay, so it's tetrahedral position. Okay, tetrahedral okay, and N effective for Zn equal to 4. Okay, so both have the N effective is 4 for S and Zn. Okay, so it means 4 Zn plus 4 S equal to 4 ZnS. Okay, so this is the structure. Okay, so since Zn has a diamond structure, right, DC structure, so it means, and for DC structure, that is diamond cubic. Okay, DC means diamond cubic. I'm writing it. Okay, for diamond cubic structure, we know, right, this is 8r equal to root 3a. That we know, right? I have already explained diamond cubic structure in my previous lecture, okay? And I have told you this is very important, okay? So 8r equal to root 3a, okay? So that's what we know here, right? So from here it is going to be 4zn, because 8r equal to root 3a. So we'll write 4zn plus 4s, okay? My apologies. So this is 4, and we are talking about radius, okay? 4r, radius of zn, plus 4 radius of s is equal to root 3a, okay? So very important point, guys, this one, okay? Since this one, this, yeah, for diamond cubic structure 8r equal to root 3a, right? So that's why 4zn rzn, radius of zn, plus 4 rs, radius of sulfate, equal to root 3a. So from here we can find the value of a. So value of a is going to be 4 by root 3, 4 by root 3, and this is rzn plus rs, okay? 4 by root 3 into rzn plus rs, rzn plus rs, rzn plus rs, okay? This is important, okay? Next we'll find the volume of ZNS, that is zinc blend structure, okay? So volume we know, volume equal to a cube. A cube means this is the value of a, right? 4 by root 3 rzn plus rs whole cube, okay? Now we'll find out atomic packing fraction. So atomic packing fraction for Zn is very important. It can be asked in the question, okay, in the examination. So APF, atomic packing fraction, is going to be, atomic packing fraction is going to be, atomic packing fraction is going to be this one, right? We know how to find the atomic packing fraction. There are 2 atoms, so it means I'll write formula first, okay? So this is going to be N effective into volume of each atom, volume of each atom, plus there are 2 atoms, right? N effective into volume of atom volume, I can write in short, volume of each atom upon the volume of the total volume, right? Volume of ZNS, right? Volume of unit cell, volume of unit cell, right? So this is the formula, guys, for atomic packing fraction for diatomic molecule, okay? I mean for molecule, okay? Important thing, because I'll use this formula for rock salt, NaCl, and CSCl for as well, okay? So this, now I'm writing the value, okay? So N effective, we have got it. N effective for, okay, here I forgot to write. So N effective, this one, right? N effective for Zn, this, right? So N effective for, that implies N effective for Zn is equal to 4, okay? Because N effective for this is 4, this is 4, and N effective for Zn is 4. Very important, okay? Okay, well, so that is the N effective. You can write it. which is actually not required, but yes, this is the N effective size. Okay, so now N effective for Zn, N effective for Zn is, we know Zn is 4 and N effective for S is 4, right? So this is going to be 4 APF, atomic packing fraction. Okay, 4 into atom of volume of each atom, right? So this is 4 by 3 pi r cube, volume of Zn atom, right? So r Zn cube, right? This is the radius of Zn atom, plus 4 into 4 by 3 pi r to the power, that is rs, volume of sulfate, right? Zinc sulfate, Zns, okay, rs cube, right? Because its radius is different, its radius is different, okay, atom, upon, that is a cube, right? A cube. So now we'll put the value. So APF is going to be this one, a cube value I'll put directly. So a cube value here, we have a cube value. So this is going to be 4 by root 3 4 by root 3 into r Zn, radius of Zn atom, plus radius of sulfate atom, whole cube, right? This is whole cube. Okay. So we just need effective atom, right? So for zinc, for S, effective number of atoms are 4. For Zn, effective number of N effective is 4. Okay. So now we'll solve it very easy. 4 to the power cube means, so this is going to be, we'll take this one, right? 4 4 16. So 16 upon 3 we have taken common, 16 upon 3 pi we have taken common, and this is going to be r Zn cube plus rs cube, okay, upon, here it is going to be 4 to the power 3 means 64, upon, this is 3 root 3 times, right? And this is going to be r Zn plus rs cube, right? So this value is going to be, this will cancel by 8 times, right? 4 times, right? 4 times. So this value is going to be, and this 3 root 3 will go in numerator and this will cancel. So this is going to be root 3 pi upon 4, and that is r Zn cube plus rs cube, okay, upon r Zn, means radius of Zn plus radius of sulfate, whole cube. Okay, this is the important thing. Okay, very important formula, APF. Okay, so this is the atomic packing fraction for zinc blend structure, ZNS structure. Okay, so root 3 pi upon 4 r Zn cube plus rs cube upon r Zn plus rs whole cube. Okay, and also we have seen the APF for ZNS is less than 34%. Right, it's loosely bound, loosely packed structure. Okay, so because it's less than, and this is less than 34. Okay, APF less than 34. I hope you have understood it. Next, guys, next structure is NaCl structure, or it is called rock salt structure. Okay, so very important, NaCl structure. The atomic packing fraction for NaCl structure was asked in NET exam, CSIR NET exam. Okay, so this is NaCl structure. Okay, NaCl structure, and this is called rock salt, ROCK, rock salt, okay. Rock salt, okay. NaCl structure, very important, okay. So it has simple cubic structure, okay. So SC structure is that SC structure means simple cubic structure, okay. SC structure. SC structure means simple cubic structure. Simple cubic structure, okay. Now we'll talk about position, okay. So Cl position is FCC octahedral, my apology, it is Cl is in octahedral position, okay. Octahedral position, and Na is FCC, okay. Na atoms are FCC, space centered structure, okay. So now the N effective for Cl, okay, N effective for Cl. So N effective number of atom for Cl is 4, and N effective for Na is 4, okay. So 4 Na plus 4 Cl equal to 4 NaCl molecule, okay, 4 NaCl molecule. Okay, this one. So the effective number N effective is effective number of atom for Cl is chlorine is 4, and this is called sodium chloride structure as well, okay, sodium chloride structure or rock salt structure. And N effective for Na, the sodium is 4 and chlorine is 4, okay. Well, so this is the one. Now we know in simple cubic structure, we know this formula, right? This 2R equal to A, right? A equal to 2R, that's what we know, right? In simple cubic structure, 2R equal to A. 2R equal to A, right? I have already explained simple cubic structure in my previous lecture, okay? So, so please check that. Okay, so 2R equal to this. So for NaCl, it is going to be 2R Na plus 2R Cl is going to be equal to A, okay, because 2R equal to A. The same case like here, this one for Zn, right? This 8R equal to 8R equal to this, right? So this is 4 Rn plus 4 Rs equal to 3, right? This is 8. Now it is 2, right? It's a 2. You need to note down. It's 2. So 2R equal to A means this is 8R Na, 2R Na plus 2 Cl equal to A, okay. So from here we can get the value of A. So value of A is going to be same thing, 2 Rna radius of sodium plus RCl radius of chlorine, okay. So this is 2 Rna plus RCl, 2 Rna plus RCl, okay. So this is the A, guys, this is important, A, okay. So from here you can and also because it's a simple cubic structure, right? So for this coordination number, that is number of nearest neighbors, okay, number of nearest neighbor, neighbors is 6, okay, 6 at A by 2 distance, okay. And second nearest neighbor, second nearest neighbors is 12. Okay, and also I have told you the trick, guys, for simple cubic, FCC and BCC, and how we get the coordination number, the number of nearest neighbors. The first nearest neighbor, second nearest neighbor, and third nearest neighbor. Right? I have told you this trick. That is STE for simple cubic, EST for BCC, and TS24 for FCC, right? STE means, because it is S means 6, 12, 8. Okay, so for first nearest number of first nearest neighbor is 6, number of second nearest neighbor is 12, and number of third nearest neighbor is 8. Okay, this for BCC, number of first nearest neighbor is 8, number of second nearest neighbor is 6, and number of third nearest neighbor is 12. Okay, these are 6, 12, and 8. Okay, and similarly TS24 means for FCC, number of nearest neighbor, that is first nearest neighbor is 12, second is 6, and third are 12. Okay, that's I have already explained. So this is the trick, so you can easily remember or memorize by trick. Okay, well, so now we'll proceed further. Okay, so now we will find A. We have got it, right? So now we'll find A. So now we'll find a volume of unit cell, right? That is A cube. A cube means this. So now we'll find APF. APF, very important. That is atomic packing fraction. Okay, for rock salt. And this is asked in CSIR net. CSIR net question. Okay, so what is the atomic packing fraction of rock salt? Okay, that is NaCl. So this we know. So that is N effective into volume of atom. There are two atoms, right? Plus N effective volume of atom upon V. I have already written this formula, guys. This one you need to note down. Okay, this one. Okay, this one. APF. N effective volume of each atom plus N effective volume of atom upon volume of unit cell. Okay. Well, so I'll write directly now instead of writing the formula, because I have already explained it. Okay. So this is going to be N effective for this is 4, right? So 4 into 4 by 3 RNA, that is volume of sodium atom, right? Plus 4 into 4 by 3 pi RCl cube for chlorine atom. Okay, upon A cube. A cube is this, right? A cube. This is 2 RNA, that is RNA means radius of sodium plus radius of chlorine whole cube, right? So we'll solve it. So this value is going to be, this is 4, 2 to the 4 to the 8, right? 4, 4, 16 means 2 pi and 3 will take common, right? So 2 pi by 3, and this is going to be R sodium, RNA cube plus RCl cube, okay, upon Cl cube upon RNA plus RCl whole cube. Okay, this is 2 pi by 3 RNA cube plus RCl cube upon RNA plus RCl whole cube. Okay, so this is the one. So this is the answer. So 2 pi by 3 into RNA cube plus RCl cube upon RNA plus RCl whole cube. Okay, so this is the formula, guys. Okay, so this is the answer, guys, and this question is asked in CSIR net exam. Okay, very important. Next structure is CSCl structure. Okay, simple, it is a CSCl structure. Okay, this is CSCl, cesium chloride. Okay, CSCl structure, CSCl structure. Okay, this is important. Okay, and so I'll write some point for this CSCl structure, cesium chloride structure. Okay, it has two interpenetrating SC structure. Okay, two interpenetrating SC structure. It has two interpenetrating SC structures, two interpenetrating simple cubic structure. Okay, so for CSCl, for CS atom, N effective is 1. Okay, for Cl atom, N effective is 1 for this, for CSCl case. Okay, N effective is 1. Okay, and 1 CS, that implies 1 CS plus 1 Cl equal to 1 CSCl. Okay, 1 CSCl, cesium chloride. Okay, and for this, this condition you need to note down. For this, radius of CS, radius of CS plus radius of Cl, okay, is equal to root 3 by 2a. Very important, guys, you need to note down. Okay, and memorize it. So atomic packing fraction, so anyone can anything can be asked in examination, like the atomic packing fraction for CSCl or Czirnet or this rock salt. Okay, rock salt is already asked in the CSIR net. Okay, so you need to know, you need to revise everything and practice, then everything is going to be in your fingertips. Okay, so RCS plus Cl, RCS plus RCl, radius of fluorine plus radius of cesium equal to root 3 by 2a. Okay, root 3 by 2a. So from here we can easily get the value of a. Value of a is going to be 2 upon root 3 RCS plus RCl, radius of cesium plus radius of fluorine. Right, very important thing. Next, volume. The volume of unit cell is simple cubic, right? A cube. So now we'll find APF for CSCl, right? Cesium chloride, APF, atomic packing fraction. So atomic packing fraction is, effective number is 1 for this one, right? And effective, that is 1 into volume of cesium atom. So 4 by 3 R CS, 4 by 3 R CS cube plus 1 into 4 by 3 R RCl cube upon A cube. Upon A cube means this one. Value of A I am going to write directly. So this one, right? This is 2 by root 3 into R radius of cesium plus radius of fluorine. Okay, this whole cube, right? So we'll solve it. So this value is going to be, if you solve it, right? So this is 4, 8, and this is 4, right? 2, and this is 3 root 3. This will go above, so this is going to be root 3 pi upon 2, root 3 pi upon 2 RCS cube plus RCL cube upon CL cube upon RCS plus RCL whole cube. Okay, so this is APF. APF equal to root 3 pi by 2, root 3 pi by 2, root 3 pi by 2 into RCS cube plus RCL cube upon RCS plus RCL whole cube. Okay, very important, you need to put down. Okay, so this is the atomic packing fraction. So, okay, well, this is the atomic packing fraction, and now now I will explain this lattice constant and atomic density. Okay, very important. Lattice, the relation between lattice constant and atomic density. Lattice constant and atomic density. Okay, so lattice constant and atomic density, guys. So this relation is very important because many questions has been asked in CSIR, NET and other exams, right? So, and using this formula you can easily solve it. Okay, so first, so lattice constant A and the atomic density rho. So this relation we have to find. Okay, so rho is atomic density, okay, and A cube, we know A is the lattice constant, guys. Okay, A cube is volume of unit cell, volume of unit cell. Okay, A cube is volume of unit cell. Okay, so now density rho is going to be that is N effective into M small m. Okay, it's a small m upon V, that we know, right? The density equal to, I'll write this first, density equal to mass upon volume, right? Mass upon volume for any crystal, right? So this is going to be, mass is going to be N effective number of atom into mass of one atom, right? This is small m upon volume is V. Volume is A cube, guys. Okay, volume we know it, that is A cube, volume of unit cell, for the volume of unit cell. So rho is N effective into mass of one atom, okay, upon A cube, that is volume of unit cell. Okay, that is the rho, right? Because it's mass upon volume. So this is mass upon volume, N effective into mass of atom, right, upon A cube. So now we know the mass m, mass of any atom, small m, is, we know, that is molar mass m upon Na Avogadro number, right? We know that, where m equal to molar mass and Na is Avogadro number. Okay, Avogadro number, Avogadro number, okay. And this value also we know, that is 6.022 6.022 into 10 to the power 23 mole inverse, okay. 23 mole inverse, okay. Well, okay, so this is the m. So we can put the value of small m is molar mass upon Avogadro number, right, in this expression. So this is going to be rho, that is atomic density is going to be rho is going to be n effective into molar mass upon Avogadro number. In place of small m, I have written m upon na. Okay, this is Avogadro number na. Okay, Avogadro number into a cube. So this is the atomic density. Okay, so from here we can get a cube value is n effective into molar mass upon Avogadro number into rho. Very important formula, guys. Okay, this one. So from here we can get value of the lattice constant A. This is going to be n effective into molar mass upon Avogadro number into atomic density. Okay, so this is very important formula for finding lattice constant, and using this formula you will be able to solve many questions in CSIR net. Many questions have been asked, and you can solve those questions using this formula. Okay, so A equal to the lattice constant. Okay, A is the lattice constant. Okay, A is lattice constant. A value is n effective upon m upon na rho. Okay, this is atomic density. Very important formula, guys. I've made a mistake. This mistake is this to the power 1 by 3 to the power 1 by 3. Okay, so this is very important formula, guys. Next, this is the relation between lattice constant and atomic density. Now we'll study Miller indices. Okay, Miller indices, very important. Okay, Miller indices of any plane. Okay, Miller indices, Miller indices, Miller indices, Miller indices. Okay, Miller indices, that is denoted by HKL. HKL. Okay, Miller indices is denoted by HKL. HKL. Okay, and for any plane. Okay, so Miller indices is denoted by HKL for any plane, and there is a relation which you need to know. H ratio K ratio L is equal to A upon OA ratio B upon OB ratio C upon OC. Okay, so where A, B and C are lattice parameters, okay, so OA, OB and OC are intercepts on X, Y, Z axis respectively. Okay, so I'll explain it by giving example. Okay, so this is the Miller indices of any plane. Just give me one second, guys. Okay, I've got urgent work. Okay, guys. So just wait. Okay. Next, I'm going to explain by example. Okay, so this is like example. Example one is like you have to explain this the mirror in so we have given 1 comma 0 comma 0. This is the mirror indices of plane given, right? So uh, we have to show that plane, okay, in crystal. Okay, so this is the 111 100 plane. Okay, 100 plane. So how we are going to show it? HKL, we know the formula. HKL equal to AOA ratio BOB ratio COC. Okay, and here we are going to show in case of cubical structure. Okay, so for cubical structure, for cubical structure, A equal to B equal to C. Okay, so then HKL value is going to be HKL. It is A upon OA equal to A upon OB equal to A upon OC. My apology, this is not equal to, it is ratio. Okay, this one. So now we'll put the value. So this is going to be 1 ratio 0 equal to A upon OA ratio A upon OB ratio A upon OC. Okay, this is the one, guys. So from here we can easily get value of A. Value of A equal to 1. Value of, my apologies, so intercepts value. Okay, OA is the intercepts on y-axis, x-axis. OB intercepts on y-axis and OC intercepts on z-axis. So OA value is A, OB value is infinite from here. Okay, infinite. OB value is infinite and OC value is infinite. Okay, so it means this plane. So because Miller indices means 110 plane. So it's a plane. Okay, so this plane intercepts intercepts y-axis on infinite and z-axis on infinite. It means uh, it is uh, this plane is parallel to z and y-axis. Okay, so how we can show in 3D, I'll show you. Okay, so this is a crystal, guys. We make a crystal first. Okay, simple cube, that is cubic crystal. This is for cubic crystal. Okay, that's fine. So this is what. Okay, this one, and we can take this as a z-axis. Okay, this as x-axis and this as y-axis. Okay, so here we'll make a plane. My apologies. So this is this as a y-axis. Okay, so this is x-axis, this is y-axis, this is z-axis. Okay, so we have to get the plane which is, because OB equal to infinite and OC equal to infinite, which is parallel to, because OB is infinite means this plane cuts intercepts that y-axis on infinite and z-axis on infinite means this. So this is going to be this plane, guys. Okay, this plane. You can see this plane is parallel to z-axis and parallel to y-axis and intercepts uh, x-axis at A. Okay, this is the 3D representation. Okay, so we have represented how this plane. What is the plane? 1 1 1 1. What is 1 0 0 plane? Okay. Now similarly, we'll find whose Miller indices are 1 1 0. Okay, 1 1 0 plane. If it's a 1 1 0 plane, then again we'll use formula, that is HKL equal to A upon OA ratio P. This is A, right, for cubical structure, A upon OB and A upon OC. So from here the values are, HKL values are 1 1 1 0. This is going to be A upon OA, A upon OB, A upon OC. Okay. So from here we'll get the value of A is going to be, my apologies, OA. OA is going to be A, OB is going to be A, and OC is going to be infinite. Okay, we have calculated it. So now we'll represent it in 3D, right? So now we have a plane which is parallel to z-axis, right? Because this plane intercepts z-axis at infinite, right? Because OC is infinite. It means we will get the plane. So there's a plane there's a plane which is parallel to z-axis. So how we'll represent in 3D? I'll show you. This is the crystal. Okay, we are showing the plane whose Miller indices are given. Okay, so we can show the any plane of the crystal if Miller indices are given. Okay, this is going to be, okay, so this is going to be z-axis, guys. We can take origin at any, we can take origin at any point, guys, as per our choice. Okay, and this is, we can take make coordinate system at any point, or we can choose origin at any point. Okay, as per our choice. This is, so this is z-axis, this is y-axis, this is x-axis, guys. So now we'll draw a plane. So this plane is going to be like this, and like this. Okay, so this plane, this is 1 1 0 plane, guys. 1 1 0 plane whose Miller indices are 1 1 0 plane. Okay, 1 1 0 plane. Here you can see this plane is parallel to z-axis, and it is intercepting x at A and y at A as well. Okay, so this is 1 1 0 plane. Okay, similarly, number third will show 1 1 1 plane. Okay, whose Miller indices are 1 1 1 plane. 1 1 1 plane. Okay, 1 1 1 plane. So again we'll find the value. So here in this case values are, values of OA is A, you can easily get it, right? OB equal to B and OC equal to A. OB equal to A, OC equal to A, guys. Okay, so cubical structure, or we are talking about cubical structure. Okay, so now we'll find the plane, okay, which intercepts XYZ at A. Okay, so I'm going to show here. Okay, so I can choose origin at any point. So I'm choosing origin here. So this is z-axis coordinate system at any point. Okay, and this is x-axis, and this is y-axis. Okay, this is x, y, and this is z-axis, right? So the plane which is cutting intercepting a x, y at a, right? This is going to be like this. This plane is going to be like this, guys. This plane. Okay, so this is the plane. This is the 1 1 plane. Okay, 1 1 plane. Okay, this is the 1 1 plane whose Miller indices are 1 1 1. Okay, so this is the 1 1 plane which is intercepting uh, x at a, y at a, and z at a. Okay, next is, so if we now we are going to represent two 2 0 0 plane. Okay, whose Miller indices are 2 0. Okay, 2 0 0 plane. So this is again, we'll do it, right? 2 0 0 plane. So I'll make a figure. So from here you can get the value of OA is a by 2. I have told you formula how to find. Okay, and OB is going to be infinite. I'm directly writing, and OC equal to infinite. Okay, so we are going to make a plane which is parallel to y and z axis. Okay, and intercepts uh, x axis at a by 2, right? So this is going to be like this. Okay, and we'll take this as a z axis, we'll take this as a x axis, and we'll take this as a y axis. Okay, now so 2 1, right? So this is OA equal to a by 2. Okay, so a by 2 means, just look at here, right? This is a by 2 here. So this is the one. Okay, and this one, z axis and parallel to y axis. Okay, this plane we are talking about. Okay, this one. Now how to this is how that is how to represent whose Miller indices are 1 bar 0 0. So 1 bar 0 0 means 1 bar is minus 1. Okay, if Miller indices are minus, so if it is minus 1, we'll not write minus 1, we'll write 1 bar. Okay, if this is minus 1. Okay, so how to represent it, Miller indices, how to show that plane in 3D. So I'll show you. So if this is the case, then value of OA is going to be minus a 1 bar is minus a, right? OB is infinite and OC is infinite. So we'll make a plane which intercepts x-axis at minus a, and y and z, and which is parallel to y and z axis, because it intercepts z axis and y axis at infinity. Okay, that we are going to make. Okay, this I'm going to make in next page. So this is going to be like this. This is the cube. Okay, and we'll take this as a z-axis, and this as y-axis, and this as x-axis. Okay, This has x, this is y, this is z. This is z actually. So this is z axis, guys. Okay, x, y, z. This is origin. Okay. So now this is going to be this plane, guys. Okay. So this plane is parallel to y-axis, right? To y-axis and parallel to z-axis. Okay, parallel to z-axis, right? And but it's intercepting at this minus a. Okay, at minus a, right? This is origin, right? Minus a. Okay, so this is the this one. Next is sixth, how to represent 2 plane. Okay, whose Miller indices are 2 2. So from here, value of OA is going to be a by 2, value of OB a by 2, and value of OC a by 2. I have already told the formula. Okay, you can just put the value and you'll get it. So here you will get it now. So we'll take this formula, right? This one. Okay, so this is z-axis and this is y-axis and this is x-axis. Okay, so here this is a by 2, means cutting this at a by 2, this at a by 2, and y-axis at a by 2, right? So this is going to be like this. This is the plane, guys. Okay, which is intercepting x, y, and z axis at a by 2. Okay, next is for this plane 1 bar means -1 -1 -1 plane. Okay, for this, how to represent it, this plane? This is simple, right? I'll write it. We know the formula, right? So it means -1, we don't write -1. Okay, we write if minus is there in Miller indices, we write by bar. Okay, 1 bar ratio 1 bar ratio 1 bar equal to O A upon OA ratio A upon OB ratio A upon OC, right? So from here, value of A is my apology, value of OA, that is OA equal to minus A, OB equal to minus A, and OC equal to minus A. So this is the plane which is intercepting XYZ axis at minus A. Okay, how to make it? So I'm going to make it. I'm going to represent this plane, okay, in 3D. So this is okay. So now we can choose origin at anywhere, right? Any point. So here we are going to choose the origin. Okay. So this one. Okay. So this is z-axis, and this is y-axis, and this is x-axis. Okay. So here the plane is going to be like this. This plane. So this plane is at you can see at x-axis it is intercepting at minus a, y at minus a, and z. This is z, right? Z at minus a. This is z minus a. X is here, right? So this is the plane. So x, this one, minus a, right? And this. So this is the one, right? So this is this is the plane which is intercepting xyz at minus a. Okay. Okay, guys. Okay, guys. So this is about the Miller indices and their representation. Okay, you can see it. This plane is intercepting these minus a. Okay. Okay, guys. So remaining part we'll do in next class. So also, I would before ending the class, I would request the student who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures, which are going to help you to crack the exams related to physical science. Okay, guys. Thank you so much. Bye now.